Okay, we have compound inequalities. This is involving and or statements. We graph them on the number line and find the sets of numbers that are included in those sets. So a conjunction is the intersection of two sets. This is where we look at the numbers in the two different sets that they both have in common. Yes?
Does the word conjunction in math have anything to do with that conjunction is used in English?
It's a similar way to think about it. Because and is a conjunction, right? Yeah. But you've also got disjunctions. Is or a disjunction? Is that called a conjunction? No, it is. And, but, and or are conjunctions. Okay. So these are a conjunction. Usually will state the word and in it because they're looking for the combination. I mean, not the combination. What's in common between the two sets? Remember we said the list of vowels and the letters in my name. The intersection of those would be I and E because my name is Michelle. I is a vowel, E is a vowel, and those are the two vowels that are in my name. That's a conjunction. It's the intersection of where they have them in common. So when I write these, I can write these in a couple different ways. I can say X is all real numbers greater than -2. X is greater than -2. And, notice there's that and there. And X is less than 5. So X is less than 5. Okay? But this is an and statement. Okay? Now, if I graph that on a number line, I start at X is greater than -2. Okay? Then I do the next one. And X is less than 5. This statement, you have to satisfy both requirements. It has to be less than -2 and greater than 5. Less than 5. Sorry. Greater than -2 and less than 5. So X is less than 5. Where is the area in both those sets that satisfies both? David?
Between -2 and 5.
Between -2 and 5. That area right in there. So that's what your line is going to look like. It starts at -2. It goes up to 5, but not including 5. That's why we have the open circle, because it's less than and greater than, but not including those two numbers. And we draw one line. This bottom line is the way I want you to draw your conjunctions. David.
So, at the end of the line, circles because it doesn't keep going on forever, right?
Right, because an intersection, a conjunction is an intersection. What they have in common, like vowels and my name, Michelle and vowels. The only thing they have in common is I and E. M-C-H-L-L. Those aren't in common. The only thing they're interested in is what's in common. And here is the area of numbers where they're in common. When it says an and statement, they're looking for what's in common. These are the numbers that are in common. Okay, questions? Okay, now we can write these as an in-between statement. Okay? And you can see we have X. I put X in the middle. X is greater than what number?
-2.
Yes. -2 on the left. But X is smaller than 5. Now notice, this is called an in-between statement, and we can write that only with and statements, not with or. You'll notice the directionality of the inequalities is going in the same way. If you got something where the directionalities were in different ways, it wouldn't work. Yes, David.
Why does it? Oh.
Because doesn't this right here mean the same thing as this?
Yeah.
And then this right here,
That's the left side. How come you flip the?
x isn't this the same definition? Notice x is greater than, isn't that the same thing? -2, -2. You're just putting it into one statement. It's called an in-between statement. You could pretty much get through this section without ever using in-between statements. They're not mandatory, but I want you to understand them. We use them for conjunctions. All right, so how would I write the in-between statement for number 1? How would I write the in-between statement for number 1? Ben, what goes in the middle first?
X.
Okay, I'm putting my x in the middle. Okay.
And then on the left, -3 is lesser than X.
Okay. -3 is less than x, which is less than
5.
Perfect. Okay. Pause the recording and do the next 2 problems on your own. Let's check our work. Number 2. Okay, now notice the way that I wrote this one to the left. Does this make sense? 5 is greater than x, which is greater than -3.
No. Yeah. No.
Well, it does make sense, but why would we not write it that way? What do you think, Peyton?
Well, I don't think it makes sense to write it that way because it already says that x is less than 5 and x is greater than -3, so you would want to put it on the left side.
Okay. Sydney?
Maybe you would want to read it like the smallest number to the largest.
Yeah, because on the number line, we like to order them the way that we see them on the number line. So make sure you're putting it from the smallest to the biggest, left to right. Okay, number 2, you should have had 4 is less than x, which is less than 10. And number 3 is -8 is less than x, which is less than -1. All right, now solving compound inequalities. We can do this in 2 ways. Okay, method number 1. What this really means is this is 2 inequalities. This means -4 is less than x plus 3. Since it's an in-between statement, it's a and statement, and x plus 3 is less than 7. It's 2 inequalities all in one. And then I just solve them. Subtract 3. What property of equality is this when I subtract 3 from both sides? Yes.
Subtraction property.
Of equality. Perfect. That's the kind of language that you're going to need on your standardized test now. For every time you throw that in, that's an extra point. They give you points for academic language. So I'm going to use the subtraction property of equality and subtract 3 from both sides of the equation. I end up with x is greater than -7. And I do the same thing here, subtraction property of equality, x is less than 4. I can write it as an in-between statement, or I can just write ahead, go and graph it. Now, a second method for doing this is instead of splitting it when it's an in-between statement, use my subtraction property of equality right away. Subtract 3, subtract 3, subtract 3 from all 3 parts of the inequality. It's really all 4 parts because that center part is really doubling for 2 equations. And then I'm left with -7, I'm left with the x, and I'm left with the 4. And bring my signs down. It takes me right into the in-between statement. Notice here, I have to rewrite it. With the smallest one, x is greater than negative 7, and x is less than 4. Here, I go right into the in-between statement. Okay, so I'm starting at negative 4, 7. My starting point, is it an open or a solid circle? Is it an open or a solid circle?
Open.
And we are going to, we're going all the way up to 4. And it's only that area, only those numbers in between are part of that set. Because that is the intersection. That is what they have in common. Sargis.
So negative 6 will like make sense, but 7 won't, right?
Correct. Negative 7 won't.
Yeah, negative 7 won't.
Right. Negative 6 and 99 hundredths will make sense. Okay. All right. We're going to make it a little bit trickier. Two-step equation. Okay. What are we going to do here? Actually, do you guys want to try and solve this one?
Okay.
Pause the recording and you guys solve this on your own.
Okay, so what I did first was I subtracted 4 from all 3 parts of it.
Okay, so you're not separating it, okay? Okay, you could have separated it. That would have been okay. Okay, and you are left with?
Negative 9 is less than 3x is less than or equal to 3.
Good. Okay, next step, please. How about Oscar? What would I do next?
Then I divided 3 from all sides of the equation.
All 3 parts of the inequality.
Inequality. And then I got negative 3 is less than x
Which-
than or equal to 1.
Perfect. And then when I go to graph it, how's this graph going to be different than the ones we've already done? Jason.
Where it's negative 3, it's going to have an open circle, and where 1 is, it's going to be a closed circle.
A solid circle, that's right. And I draw the line. Perfect. Okay, questions? Yes.
Why is it a solid circle? Why is it an open circle on the negative 3?
Because it's just less than.
It's not equal to.
Are you hearing them? Do you see this one is less than?
Right.
So it's open. And this one is equal to, so it's solid. Okay. All right, they're going to get a little bit trickier. In this situation, what do I start with first? Yes, Rogelio.
Don't you subtract 6?
Yep.
Okay.
And then I'm left with
Negative x.
No.
Negative.
left to right.
Oh, left or right?
Just like reading a book. What am I going to be left with on the left side?
Okay. Negative 10 is less than, is less than or equal to negative x.
Negative x, which is
Greater than, less than 8. Negative 14. I don't know.
positive 8,
I'm too close.
negative 6. You've gotten everything right except the end. I don't know. You're not totally confused because negative 4, negative 6 is, in fact, negative 10. You got that right. You brought down the less than or equal to. You canceled those out and you're left with negative x. You were right. Now you're just left with positive 8 and negative 6.
2.
What kind of 2?
Positive.
Okay, is less than positive 2. So you weren't completely confused. You knew a majority of it. It was your own confidence all of a sudden doubting you. All right, so now, am I done? Has X, Peyton, what would I do now?
Well, now you're going to divide each side of the inequality by negative 1.
By negative 1.
But because you're dividing by a negative, your inequality symbol signs will have to switch.
And so now it will move like this. You with me? You should be writing it down, not just staring, so you have something to refer to. Negative 10 divided by negative 1 is 10. X comes down, and I'm left with -2. Now, is that from least to greatest?
No.
So how am I going to rewrite it? Sarkis?
-2 is less than x is less than 10 or equal to 10.
And then I graph it. -2, 10, open circle to solid circle. 10 is included in the set, -2 is not. Yeah.
Is it okay if you multiply by -1? Will you still get the same
If
outcome?
you do that, you still have to flip the sign. Sure.
That's the same thing.
Yep. All right, so now here's what we call a disjunction. Now, a disjunction is an or statement. Dis kind of makes it sound like it's broken up, which is kind of a disjunction is where there is a breaking. This is the union of two sets, meaning these numbers or these numbers. So if I ask for the disjunction of the vowels and my name, it would be MICHELLE plus AOU. Do you understand? It's the letters in my name or the vowels. It's the combination. Now, we call this an OR statement. It's these numbers or these numbers are allowed to be in the set. Now, let's write this. Numbers, now look here. It's very different. In the other problem, you had an AND here, and here you have an OR. So we have all real numbers less than -2. X is less than -2. Or all real numbers greater than 5. X is greater than 5. This is an OR. Let's look at this on the number line. Okay, the first one, we're starting at the -2. It should be an open circle. And what direction does it go to?
Left.
It goes to the left. And the second one is starting at 5, and it goes to the right. So the numbers in this number set, oops, I didn't mean to do that. The numbers in this set really kind of start at -2 1/100th, 2 200ths, 3, all the numbers in between there. And or 5 1/10, 5 2/10, so on and so forth in that direction. But not these right in here. These are not included in that number set. Does that make sense? Okay. So in a disjunction, the graph, the lines are kind of broken up. It means the numbers in this set can either be here or here. Doesn't have to satisfy both and be an intersection. We can never write a disjunction as an in-between statement with one variable. Okay? When that happens, both inequalities are going in the same direction. Okay? All right, so I have made a little bit of a chart here. I kind of added to this. I made a chart, and I tried to use a little bit of numbers here. I've got the conjunction, which is an intersection. That's what's in common. Most of the time, you're going to get one number line. Here's how it's going to look. Or it would be Either one of those. Most of the time, and it's all the numbers from here to here that are in common go in that set that satisfy both statements. A disjunction is a union. It's an or statement. It's where all the numbers less than -2, or it could be any of the numbers greater than 5. So less than -2 or greater than 5. Okay, yes, Peyton.
Well, when you're after you graph, if you're doing a conjunction, after you graph it, and you're writing the numbers in your set, does it make a difference if one of the points on the number line is closed or open?
No. Well, we'll look at a couple different situations. All right, let's look at this one. Yeah.
There's something like wrong with the conjunction thing.
Uh-huh.
It says x is less than -2, but I'm just.
Oh, whoops. It should be x is greater than. Yeah. This should have been. Good catch, Sarkis. Okay, x is greater than -2, but less than 5. You put it into the in-between statement with the x in the middle, your signs will be facing the same way. All right, so in this case, we're just going to solve them, and we graph them. Most of the time, like a majority of those problems, you're going to solve the inequality, and then you're going to graph them on a number line. And when you graph them, you'll see what it is. You'll see, most of the time, something with 2 lines going in opposite directions is a disjunction. Okay? When I do something like this, don't forget, if you're dividing by a negative, you have to flip your inequality sign. Okay? Again, does this look like a disjunction or a conjunction? Is it an or an and statement? All numbers greater than 12, or, now, wait, who asked this question? Does it matter? Notice in this one, to the left, for the -7, that's a solid circle. That just means it includes it. Who asked that last question? Was it Sargis? Okay. All right, let's look at some exceptions. These are exceptions. Do you guys need more practice on that? Lucy, you look confused. Are you feeling like you need? Okay, let me go through the exceptions and we'll go back to some practice problems. Majority of the time you're just going to do it and you're going to graph it, and the graph will show your set of answers. Okay. If I have something like this, I want to use the statement that describes the intersection of these. Okay? The statement that describes the intersection. Remember, the intersection is what's in common. So, in this case, I'm going to graph each one. Okay, we've got x is less than 5. That's x is less than 5. And then I've got x is less than 3. I start at the 3. Which statement, this one's x is less than 3, covers the intersection, the combination, the overlap? The x is less than 3 or the x is less than 5? Sarkis, what do you think?
The x is less than 5.
Covers both.
Yeah.
Okay. What about this area in here? That's not both there.
Oh.
What?
So it's the 3 because
It's really this one, x is less than 3, covers the area where both intersect. Do you understand? So x is less than 3 is a good statement to describe that intersection. Okay? And we would show that x is such that x is less than 3. The numbers in this set are going to be x is such that x is less than 3 because it will cover the intersection. Okay, now look at this union. If I graph this one, x is less than 5 and x is less than 3. This time I want the union. Do you understand the difference between union versus intersection? I'm going to draw them both. X is less than 3 and x. Which statement, this is x is less than 5, this is x is less than 3. Which statement describes the union of both of those statements? Sarkis.
So this time it will be x is less than 5 because it has more numbers?
Yeah, because it covers the combination of both.
So
These or these. Do you understand, guys?
Yeah.
So if I'm writing this, x is such that x is less than 5 will cover that union. Ben.
So on the number line, would you be able to just write x is less than 5?
Yes. So look here. If I erase it, that's what my PowerPoint does. He just asked if you erase it, you're allowed to write just because that number line covers the union of both. Do you understand? It's got all the x that's less than 3. All those numbers are in that set of x is less than 5. Okay, now the next one. I think these slides will make a lot more sense to you when you go home and play with it a little, and if we go back over this slide tomorrow. Okay, this time I'm starting at x is less than 5 and x is greater than 3. What's that graph going to look like, Oscar?
I have a question about something else.
Okay.
What does that mean, the circle thing, like x, dot, dot?
X is such that it's what do we call that? Who remembers? Yes. It's set builder notation. It's just the fancy way to write it. We did that in 9-1. Were you here the other day?
Yeah, I have it in my notes.
So all that, it's just writing it in set builder notation.
That's it?
Think of it as fancy writing. It's the rule. Okay? All right. Now, for this one, where am I going to start? I want to hear from somebody other than Sarkis. What am I going to graph? Let's graph them both to figure out which statement best covers both, or do we need both? Look what I'm going to do. X is less than 5. X is greater than 3. This is an and statement, so that means it's the intersection. Intersection. So we need what's in common. So it's going to be just here. You guys with me? How would I write that in set builder notation? What do you think?
x is such that x is less than 5 and x is greater than 3 and x is less than 5.
Perfect. You're just going to put both of those in that rule. Or you could write it as the in-between statement, but both ways are accurate. You can write it both ways. You could say x is such that x is less than 5 and x is greater than 3. Close parentheses. That's the rule that covers all the numbers in that set. All right, now the next one. Less than 5 or greater than 3? Less than 5. Now look what's happening here. Hold on. So, when it says x is less than 5, that's the first line, and then it says x is less than 3, that's the second line. It needs to cover both of those, and that's why they wrote only one line, because in this case, x is any real number. Okay? Any real number. Okay. Let's look at this one. This is an intersection. What does an intersection mean? What does an intersection mean? Sarkis.
That things are in common in both sets.
Hold on. I'm sorry. I'm still recording. Go on.
Things that are common in the set.
Now, x is less than 5. Less than 5. No, it's greater than 5. And x is less than 3. Look at this situation. What is the rule here? Yes.
There's stuff that are in common in both sets, which is nothing.
Nothing. It's an empty set. Okay? 3 more number lines to look at. Okay? So on this one, we've got the union includes all of that or all of that, and we just write that. There's no way to combine that. All of the numbers less than 3 and all the numbers greater than 5. This is x is greater than 5, and this is x is greater than 3. But we need the combination where they're in common. Greater than 5 covers where they have the common. Does that make sense? And then the last one is where x is greater than 3 versus x is greater than 5, where it is the combination is x is greater than 3. And that's the